As soon as you say the natural log, you automatically know you're talking about base e. Are these logarithmic growth or logarithmic decay? Is that a raised hand? Yes. Yes.
So is the log base e to the x the same as ln?
I'm about to address that. Yes. Yep. Good. But yeah.
That's 2 point something and that one is.
This is 2.718. That's bigger than 1. It's growth. 10, bigger than 1, growth. So both of these are growth. Now, the function log base e of x is written because it's used so much and it's so damn special, we write it that way instead.
Oh, yeah,
You've seen that before?
I didn't know what the hell it was.
Yes, that's what it is. Now, it's actually an L and an N.
It's a natural log of x.
It's French, I think. Logarithmic, natural. I'm not French. But you know how they say things backwards like that. So it's actually log natural instead of natural log. A lot of people think that that's an I. It's an ln. So it's ln x. That's the natural log function. And then if you want to talk about the base 10 log function, we have a special notation for that. And we use the notation log x. That's it. So it's kind of like this. If I write cube root of x, everyone knows I mean cube root, right? If I write this, what do I mean? Square root. I don't write the 2. Everyone knows it's a 2, right? Well, when you write a log and you don't write a base in here, it's understood to be 10. It's understood to be 10 if it's not there. Now, go ahead.
So just like, that's why it always just says log whatever in the calculator, because everybody assumes that it's.
Yes, your calculator has an LOG button, which stands for the log base 10 button.
Can you change the base?
You can. You can. So let me, hold on. I'm going to get to the, we're going to get to the calculator here in a second, but let me just explain something. Yeah, we are going to have a calculator quiz. I promised one.
Wait, like
Good.
today?
I brought it.
We're going to do it today. Yep. Good. Good. Then you're going to get 100.
It's in my bag, my other, in the truck.
Okay.
Yeah, the one
Look,
that didn't bring it.
let me continue here. Don't worry about the quiz yet. As a student, I just took this, when I was learning about logs, okay, natural log, they just want to use ln x, fine, and then log, they don't want to use the 10, they just want to write log, and I just accepted it, and I was okay with it. But then I got into this perspective as an instructor, and I said, why? I mean, what's the hassle in just writing the base there? I mean, just write the base, right? Just write the base. When you start doing this stuff, then this becomes mysterious. For some reason, people don't see the base here anymore, and they lose sight of the fact that when you have, if I write something like this, natural log x equals 2, they completely forget what the question is that this is asking. What is that asking? It's saying
E to what power is x?
it's saying e to what power?
It's 2.
No, hold on. It's saying
2. 10 to.
No, e to what power is
2
e?
equals f.
this is.
To what power is e?
Okay.
Oh no, or e.
Hold on. What is this saying? See, you've already lost it. Let me do it this way. What if I write it this way? What if I write it this way? And then think a little bit about that loop for a second. What is this saying?
Oh yeah, e is the same.
E squared is x, right? E squared is x. That's what that's saying. E squared is x, right? But when I write this down, people are like, and you lose it because it's not there anymore, right? So you kind of lose sight of what's going on. Same with log. If you write like log, I'll do it this way, log 100. That's super easy, but people just look at it for a while. They're like, let me get my calculator out. But that's just saying what? 10 to what power is 100? 2, right? So as an instructor, I'm sitting here, I'm like, well, why in the hell do we do that? Why don't we just leave the base there? And then I looked into it, and there's actually a pretty good reason, all right? Back, you're thinking about like these logs are being used a lot in scientific papers, people who are doing research at universities back, long time ago, early 1900s, late 1800s, and they're writing these major papers on results that they're getting when they're doing these experiments. We're talking papers that they're publishing that are hundreds of pages long, that have logarithms in the calculations written hundreds, if not thousands of times in their paper. And they used to do it in a typewriter, with typewriters. And I don't know if anyone here has ever used a typewriter. So you have. Y'all know what a typewriter is? Okay, all right. I'm not trying to insult you, but I'm just saying, I want to make sure. So
Those are the old style
you and it's like, and how do you subscript on a typewriter? You actually can. You have to do this little like single click and like rotate. It's like a half rotation of the little drum thing, and then you go, and then you go back, and then you can continue. And then every time you would do log base E or log base 10, you would have to do that. And if you're doing that, a lot of times that's a pain in the ass, isn't it? So they just all agreed that we would use a shorter notation like this, and if you type lnx on a typewriter, there's no stopping. You just keep going, right? And same with this. And so it was just out of convenience that they wanted to use that. We don't really need that anymore, because, subscripting still sucks on word processors unless you know shortcuts, right?
Even with the shortcuts, it takes time.
Yeah, even then, right? So subscripting has always been a problem. But that's why we switched it, all right? Do not lose sight of the fact that it's just regular old logs. Look, if I throw log base 4, fine. Log base 10, you might forget it's 10. It's just,
So if you just
got
say
it?
log 10, then you have to assume that the other one is 10 as well.
If I say what?
If you just say log 10 without putting a base, then you have to assume that.
That's right. The answer to this would be 1.
1.
Okay, we're doing good. 212, exact value, good. So let me ask you what this is then. Some more properties. What's the natural log of e to the x? So I told you it was going to mess you up. Just x. Good. That's just x. Now I'll try and help you by showing you the long version. That's really log base what? E of e to the x. That's what that really is saying, isn't it? And so that's saying e to what power is e to the x? X. So the answer here is x. Another way you could have thought through this is to say, all right, e to the x is an exponential function, right? What's its inverse? It's a log function base e. So what happens if I take that and I plug it into the log function base e? They should kill each other off and spit out x, right? So I've composed, used composition to put an exponential function together with its inverse. And so it should just spit out the x. Let's try this. What's e to the natural log of x? That's also x. It's the same reversed, right? This is kind of like f of g of x, and this is like g of f of x, backwards. Was that or?
I'm seriously confused on that second one.
On that second one, well,
E of L of N.
this is really e to the log base e of x is really what that is. And we showed a second ago that a to the log base a of x was x. We showed that. That was the thing we did with m. M was equal to x. So it should work with any
Yeah, I'm definitely
any
saying
base.
know about how the notation is going to kind of screw us
Yeah, the notation is just hard to get used to, and especially when they switch it from this to the natural, it starts to look even more foreign. I'm just going off of history, okay, like what I've seen from students.
But if we do a bunch of these, I'm sure we'll get there.
Yeah, eventually. It's like anything else.
Theory. Enough practice, good makes perfect.
Okay. There was something. Oh, I was like, there's something I wanted to talk about. All right, it was the base system, but let me finish this up and then we can talk about it. Simple log equations. Simple log equations. Man, there's something on me. We've already done simple exponential equations. You don't have to go to your car to get your calculator. Don't go to your car to get your calculator. No, don't worry about it. Don't worry about it. That's a simple exponential equation, right? And we even did things, like I started out class, we could do something like this. 10 to the x equals 1 over 100, right? We can handle this. These are simple exponential equations because we could get the same base on both sides. Okay, now let's look at some simple log equations. How about log base 2 of 3x plus 1 equals 3? Can you tell me what x is? This is the same as 2 to the third equals 3x plus 1. So I don't know if you used the loop that I talked about earlier, but that's the way I would want you to. Okay, that's transferring that log into the exponential form. That's what you do, right? So 8 equals, this is linear now, right? Linear equation, just solve. 7/3 is x. Simple log equation, nothing special going on here. It just looks weird, yeah. How about natural log of e to the negative 2x equals 8? Negative 4. How'd you do that?
I put it into logarithmic form, and then, yeah.
So did you rewrite the natural log as log base e?
Yeah.
You did that? You did log base e of e to the negative 2x equals 8. And then what?
And then just cancel each other out.
To the 8.
Did you do the loop? Is that what you did?
Yeah.
Okay, so you did this to that, right? Like this. So e to the 8 equals e to the negative 2x.
Because they have the same base.
And same base, so this should mean 8 is negative 2x, so negative 4? Yes? That's one way. Any others?
Wouldn't the natural log of e always not cancel out, but it would just be the exponent because it's
That's right. We just had that. I just put that on the board a second ago. Remember this? Right? Natural log of e to the x is x. You could have gone straight from here to negative 2x equals 8.
But in this case, do they actually cancel out? Or what?
They're inverses, so they undo each other. So it's kind of like whatever's up here is what's going to fall out.
So then, if you were to put log 10 raised to the x equals whatever.
Log 10.
Not adding a base, so it's just implied base 10.
I'm not following you.
log 10 raised to something,
Okay.
and then equals.
Raised to the hello
Yeah, raised to the hello
equals hello.
yeah.
Yeah, that's right.
Oh, okay.
In
It's kinda
reference
like-
to the L of n e to the x equals x, like, if we
Yes.
sum our variables from the problem that was asked, like, how would we solve it using that method?
Do what? Using this?
Yeah, when using the variables we were given.
Well, this right here is like a box, right? Natural log of e to a box is the box. So when I say natural log of e to a box equals 8, then this right here, this side is just the box, isn't it?
Yeah.
It's like these drop out and this is what's left.
I guess the easiest way that I can think to explain it is that you have the same number as the base. I
The
guess.
way I look at it.
Yes, this is the same as the base. When these two are the same, which you can't see the base here, then they wipe each other
I
out.
just kind of ignore the log and then just set them equal to each other.
So then, like,
Once it's equal to, like, the exponent, it's always going to equal whatever is, you're trying
Yeah.
to find.
Yeah.
Then, like, just
And
to
then
make sure
just
I'm
solve.
understanding this correctly, log base 18 of 18 raised to whatever equals whatever.
Whatever, yes.
Okay.
hmm
Gotcha.
Yeah, look, this is the property we hadn't written this. No, did we write this property down?
Uh, somewhere.
I think I had y'all write that down.
Yes, you did.
That's exactly what you're saying. So you're saying if log base 18 of 18 whatever, that should be equal to whatever.
Yes.
Yep.
We did it on the F of G one.
Yeah.
Yep. And we did it the other way around too. We did it if you do a to the log base a of x, you also get x. So that means if I have e to the natural log of 2x equals 8, I changed the problem a little bit, but, well, you know, I'll make it this, negative. Okay, then what's the answer? -4. That'd be the exact same thing. Do you see that? These two would basically wipe out and become just up here. Now, this isn't wrong, okay? This isn't wrong. I'm just pointing out that
This one.
the shorter way would have been that. Okay, I'll let you mess with those. So, what do you think? Do y'all want me to talk about number base or no?
Yes.
Yeah.
I just have a question.
Yeah.
How do you change the base of a log on the calculator?
Let's do that.
I
Let's do
don't
that.
know.
Okay, it's all going to depend on your calculator. Some calculators, depending on what you have, will allow you to put the base in yourself. Okay, so this is in the book. It comes later. I'm going to give it to you now. All right. This is a very important note. It's called the change of base formula.
And I assume you're explaining it in the scenario that you can't change the base in the calculator?
Most calculators don't let you change the base easily.
On mine, like I have to go in the catalog and it says I have a function of log
Mhm.
and it says log base. So on
Yeah.
log base is that way?
Yeah, I wouldn't even mess with that. I've got that same calculator. It's too much trouble. Just watch.
Okay.
This is a great formula. All right. Here's what it says.
Does it matter?
If-
I have that same calculator, it sucks.
Let's say we're trying to figure this out, right? The change of base formula, which I'm not here to prove to you why it's true. Okay, this is one of those things you'll just have to take on faith.
Because my teacher said so.
Exactly. All right. Is I wrote the wrong thing. No.
I've seen that somewhere. Don't know where.
That's the change of base formula. Now, let me explain what's happening here. If you're given, as an example, what is log base 4 of 5? Or you know, better yet, do you have the problem that you had the other day that I said we would do, but
Yeah.
stay tuned?
Oh, yeah.
What was it that we were trying to do?
It was.
5 to
5 to what power?
3x minus 1
Yeah.
equals 8.
Oh.
Yeah, what she said.
Okay, let me do that after I do. Let me give you a simple one. Okay.
I like he was like,
Yeah.
We won't do that one after.
I'll do it right after this one. I'll do it right after this one. Okay, I want to start simple though. What is this log telling you to do? It's saying 4 to what power is 5? Good luck. That's not happening, right? You're not going to think of that.
Right.
But according to this formula, a is 4, right? X is 5. This should be the natural log of 5 divided by the natural log of 4. And the good news here is that everybody's calculator has the natural log key. And so you don't need to ever change your base. And that's why you buy a $150 calculator and it only has a natural log key on it. They know you don't need the others. You only need one.
And a formula.
And the formula, and you can do all logs. So
But it would be 4, 5.
now you have to do them separately, okay? Be careful. You cannot do this, okay? We are not saying to do the natural log of 5/4. So I would like everyone to try this on their calculator and see if you can get the right answer, and I'll tell you what it is.
The natural logs cancel each other out.
No, 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 no. Careful. Remember, natural log 5, natural. These are functions, right? The natural log is not like a variable. It's not like x where you can cancel the x's. It's an actual function. You have to figure out what happens here, what happens on the bottom, separately.
So would you have to put both natural logs in parentheses?
1.1609.
Yeah, it's going to depend on your calculator. So I'll walk around and let me tell you what the right answer is first. Let's see.
The elephant.
You should get approximately 1.161. Anyone not get that? If you didn't get that, I need to show you how to do it on your calculator. Were you able to get it? Okay. Use of parentheses is real important on things like this. No one had a problem?
I didn't need a calculator. I just did it in my head.
So do y'all understand what I'm saying? Like, with this formula, you don't need to change your base. Anytime you have a log, you can always just use your ln key. And it's actually pretty amazing, although you don't need this. This actually works out. You could actually do log instead of natural log, and it would give you the same answer. So like if you just preferred the log key instead of the natural log, you would get the same exact 1.161.
But natural log don't have to have different bases.
I know, but it doesn't matter. It's crazy. It's a great result.
Is that just a thing, like, just because the teacher says?
Well, I mean, if you want to come sit down in my office and we go through a proof of that, I mean, it's not something I can do quickly and easily on the board here. Yeah. If it was like a nice result that I could say, yeah, and this and this and see, it's that. It's not that simple, unfortunately. All right. Shall we do the one we couldn't do, and then I'll talk about base systems some other time. Everybody go cut off 2 fingers, 1 on each hand, and then do that for a month. And after everyone's lived with 8 fingers, we'll start trying to understand base 8.
I mean, I've broken some fingers and it kind of sucks.
No, you got to cut them off. Okay. Extra credit? I'm just kidding. How much extra credit? I don't know.
Once we cover that, can we cover base 6?
Well, if you need more extra credit, we can talk about base 6.
I'm on 8 and all 2.
What was the problem?
So it was 5
If
base
my has access
3x
to
minus 1
narcotics would be good.
equals 8.
Okay. This is going to wind up being a pretty easy problem now for us.
I want 100.
Does everyone remember that we couldn't do this problem because we couldn't get the same bases?
Yeah.
Right.
Guys? We couldn't get the same bases, so we couldn't do the little short way. Now we have logarithms. So I'll ask first for us to convert it to logarithmic form. Log base 5 of 8 equals 3x minus 1, right? Now the left-hand side of this equation has numbers here and here, which means you can use your calculator. No. If you do this loop, you can go back to that. What I'm saying is this side now becomes natural log 8 over natural log 5 on your calculator. And the right-hand side, well, we'll deal with that in a little while.
Oh, and then you just.
And then it's a linear equation. So do on your calculator natural log 8 over natural log 5 and see what you get. 1.292. Any seconds on that? Yes? Okay. And now you solve for x. It's a linear equation. So add 1 to both sides. Divide by 3. You're going to get a decimal answer, but let's see. If I add 1, I get 2.292 equals 3x. Divide both sides by 3. You get something like 0.764-ish, approximately. There you go.
Bam.
So that's, with what we've done today and that last little change of base formula, this is now pretty straightforward. Pretty straightforward, right?
Surprisingly.
Okay, let's get a piece of paper going around. Everyone, just whoever's going to sacrifice a piece of paper, everyone needs to sign it today. That's going to be your calculator quiz. Are you the only one who doesn't have it? Anyone else not have it?
I do not.
You
I
don't?
usually bring
You
my
weren't here
bag.
last time, right?
I was not here last.
I told everyone to bring it.
I usually bring my other bag, but I always.
Sign in. Cut a finger off this weekend. I'll give you the credit.
Do we get more credit the more fingers we cut off?
Yes, it is. It is actually exponential. You cut off 1, I'll give you 2 points. You cut off 2, I'll give you 4 points. Cut off 3, 8.
If I can like convince a friend to like donate.
No, it has to be your fingers.
Are you gonna like fingerprint it? Like make sure it's us?
I'm not sure.
I think.
I can do it on my pinky toes. I mean, get rid of them things. All I
You're-
do is stuff the freaking dresser in the middle of
Your
the
big toe, you get an A in the class.
While you're at it.
I don't think you can walk without a big toe. From what I've heard.
Yeah, you can't.
We have to like wait.
Yeah,
Okay.
just like get rid of the middle one. It's like you're barely using it at all.
There's a while the sign-in sheet's going around,
No, it's so weird.
there's a famous, not a famous, it's an equation. It's kind of weird looking.
Oh, the one that I got the red ones? Yeah, I got rid of them. They were too awkward.
You all know what like 0.11111 forever is, right? Is the sign-in sheet already around? No?
Yeah, we're doing it.
Okay. And this can't possibly be true, can it? Can 1 be equal to 0.11111?
Wow.
It doesn't seem like it can be, right?
Without some sort of function.
They look, I mean, they're not the same, right?
That is.
Hmm? Well, I guess what I wanted you to think about is what's 0.111 mean?
That just means one repeating.
Isn't this mean 1/10?
Yes.
And doesn't this mean 1/100th? And this means 1/1000th? And what you're doing is you're just adding those together, right? So if I add these two and these, and I keep going, and that's what I get, right?
Actually reach 1.
Huh?
Shouldn't you eventually?
Hold on, just hang tight. Is that what that means?
Yeah.
Okay. If I were to write 0.21211 forever, this would mean 2/10, right? That's what this is, 2/10. 2/10, 2 times a tenth, plus 1/100th, right? And then this 2 would be 2/1000ths. Do you agree with this? Okay, what I'm trying to allude to here is that base 10 system means when we write a number down, like I'm going to give you another number, 3.42. Let me go 23.42. This 2 means I have 2 10s, right? Plus, this means I have 3 1s. The decimal point means I have now 4/10ths. This 2 means I have 2 100ths, right? That's what that really means. If I rewrite this, this is 2 times 10 to the first power plus 3 times 10 to the 0 power. Isn't 10 to the 0 1?
Yeah.
plus 4 times, isn't this 10 to the negative 1? Plus 2 times 10 to the negative 2, right? So do you see that each one of these is a power of 10? And the numbers are just how many of those we have. That's what base 10 is all about. Every digit is a number, that number, times some power of 10. With me? What's base 2 number system mean then? Okay, so this is what base 2 number system means. With base 2 number system, you can only have zeros and ones. You only have 2 numbers to work with. Base 10, you have 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But with base 2, you only have 2. So in base 2, if you write the number 1, 0, 1, 1 down, okay, in base 2, this first number means I have 1 somethings. This number means I have 1 something. And this one means I have 0 somethings. And this one means I have 1 something. Got it? Base 2, so go back over here to this. The 3 was 10 to the 0, right? The 3. So what do you think this first one's going to be if we're in base 2? 2 to the 0. And then this one would be 2 to the 1, 2 to the 2, and 2 to the 3. Okay, so let's tell me what this number is. You have 2 cubed, which is 8 times 1. This is 8 plus 0. This is 2. This is, that's a 1, and so 1. So this is 11. That's the number 11 in base 2. That's the number 11 in base 2. Okay?
That's weird.
I know that's weird. I know that's weird. So then the question is, I'm going back to, see, I don't know how I've somehow kept you here. I'm going back to this now, 0.1111, right? I said that was equal to 1. But I tricked you because I didn't tell you this right here, that's a base 2 decimal. So this means I have 1 what? Not 1/10, 1/2. See, because it's base 2. Plus, I have another 1, but this time instead of 1/2, 1/4. And then I have 1/8. And then I keep going. 1/16. All right? Got it? So let me convince you that that's 1. Because it goes forever, right? All the way across the room is 1. First I add a 1/2. Right? And then I add a 1/4. And then I add an 1/8. Then a 16th, 32nd. Keep going half, forever. And I reach 1. I can't ever get there, but this is called an infinite sum. You study this in Cal 2, but that's basically me trying to very, very lightly prove to you that you can write this down if this is a base 10 number and this is base 2. Then that's true. If anything, I hope that you took away from this, like what each digit means in a number system. Each digit just tells you how many of that base to certain powers are. Yes?
Does that explain like whenever you said that 3.99 repeating is 4 because you're getting infinitely closer infinite times?
Pretty much, yes. But it's different because I'm in a different base system, but yeah. Okay, sorry, y'all go. Everyone signed in? Tomorrow's April Fool's. Don't let anyone get you.
We have bus tomorrow, guys.
Yeah, that would suck, man. I'll just like show up and he's just like got this like hidden camera.
Yeah.
See who will show us.
I'll set it up and I'll just have it there and you'll just think it's normal. Oh, he's going to be here.